Chapter 6 discusses linear equations, specifically on how to find slope, slope-intercept form, x and y intercepts, standard form, and parallel and perpendicular lines. Before you begin this lesson, you'll want to make sure you download the PowerPoint. Be sure that everything that we are writing on our PowerPoint slides are written on your PowerPoint slides. Once you have your materials collected, you may begin.
Slope is the steepness of a line. Slope can be also called constant rate of change. Slope is m equals y2 minus y1 over x2 minus x1. Another way of saying this formula is rise over run, or the vertical change divided by the horizontal change. An example of finding slope given 2 points will be shown on the next slide. Okay, we're going to find the slope of the line that passes through the points -2, -2, and 4, 1. We're going to use the formula m equals y2 minus y1 divided by x2 minus x1. First, we want to identify our points, our x's and our y's. So we have -2 and -2 is our first ordered pair. This is the x, and this is my y. The other point we have is 4, 1. This is my other x and my second y. So if I take my two y values, -2, and I subtract my other y value, 1, draw a fraction bar, and I'm going to subtract my first x value, which was also a -2, and I subtract my second x value, which is a 4. -2 minus 1 gives us a -3 for the top, and that would be our vertical change. -2 minus 4 gives us a -6, which would be our horizontal change. We can simplify this further to 1/2. A negative divided by a negative makes the whole answer positive, and 3 divided by 6 reduces to 1/2. So this slope of the line that passes through these 2 points would be 1/2. Your answer here is m, or slope, equals 1/2. To find the slope of the line that passes through the following points, we're going to identify our x and our y's in these ordered pairs. And I'm going to take my first y value, which is a 5, and I'm going to subtract my second y value, which is a 4. All of that goes over top of my first x value, which is a 3, and I'm going to subtract my second x value, which is a negative 1. 5 minus 4 is 1, and 3 minus negative 1 gives us a 4. The slope of the line that passes through those 2 points is 1 over 4. For this example, we're going to again identify our x and y in our ordered pair, which makes it easier writing our y's over top of our x's. We have our first y value, 3, and we subtract our second y value, which is 1. Put all of that over top of our first x value, negative 5, and we always subtract our second x value, which is 2. 3 minus 1 is 2, and negative 5 minus 2 is negative 7. Therefore, the slope of the line that passes through these 2 points is a negative 2 over 7. Notice that when one negative is in your answer, either on the top or on the bottom, the entire slope is negative. Had there been a negative on top and bottom, the entire slope would have been positive.
Slope can be expressed in different ways. One way to help you remember the ways that slope can be expressed is by using this K shape with the line through the middle. The vertical line has a slope of undefined. A line that looks like it's going uphill from left to right is a positive slope. A horizontal line is a line that has a slope of 0. And a line that looks like it's going downhill from left to right has a negative slope. You can use the letters U for undefined, P for positive, and O to represent the 0, and an N for negative slope. The word upon to help you remember undefined, positive, 0, and negative slope. Now we're going to determine the slope of a line. When we look at this line, we can see that it has 2 perfect points. A point at negative 2, and a point at 4, 1. We are going to use a triangle from one point to the second point to be able to determine the rise over the run. So to see the rise, we start at the bottom of the triangle, use that as 0, and count up 1, 2, 3. So our rise is 3. We will put a line to show over, and then we do our run. From the same spot, we're going to count over to the next dot. We go over 1, 2, 3, 4, 5, 6. So our run is 6. So our slope for this line would be 3 over 6, or we could reduce that to 1/2. Now we are going to determine the slope of this line. Before we can do that, we need to find perfect points on a graph. The first perfect point is at 0, 2. The other perfect point that we're going to use is at 1, 0. Now that I have my perfect points, I can find my slope by using rise over run. So I'm going to draw my triangle from one point to the other. When I look at this line, I can determine if it is a negative or positive slope. This line is going downhill from left to right, so it would be a negative slope. Now I'm going to count my rise and my run to get the rest of the slope. From the point at 1, 0, I go up 1, 2. So my rise is 2. and I run from the point here at the triangle over 1. So my slope would be negative 2 over 1, which can be reduced to negative 2. Now we can use what we talked about in the past two slides to find the slopes of the following lines. The first line that we look at, we can see that it is going uphill from left to right. So this would be a positive line. We can find two perfect points, one being at 0, 5, and the other at negative 4, 0. I'm going to make my triangle from one point to the other to be able to find my rise over my run. From the point at negative 4, 0, I rise 1, 2, 3, 4, 5. So my rise would be 5. From the corner of the triangle, now I'm going to run over to my second point, which would be 1, 2, 3, 4. So my run is 4, which makes the slope of this line positive 5 over 4. The second graph that we are looking at is a line that is going down from left to right, which means that it is a negative slope. Now I can find two perfect points to find the rest of the slope. One point is at 0, 2, and the other perfect point is at 3, negative 2. I'm going to make my triangle from one point to the other to be able to find my rise over my run. From the point at 3, negative 2, I rise 1, 2, 3, 4. So I'm going to put 4 on the top. From the corner of the triangle, then I run 1, 2, 3. So my run is 3. The slope of this line then would be negative 4 over 3. Now we are going to look at the slope of these two lines. The first line that you see is a horizontal line, meaning that it goes across from left to right. This line always has a slope of 0. It is important that you remember that a horizontal line's slope is always 0. If you look at this, the run you could determine, however the rise you could not. And whenever you divide 0 by a number, you always get 0. The second line that we have here is a vertical line, which means that it runs up and down. A vertical line always has a slope, what is called undefined. The reason it is called undefined is because you would not be able to determine what the run of this is. The run is 0. And the division of 0 by any number would give you an answer of undefined. We are now going to plot the point of 2, 0 and use the slope of 3 to draw a line on this graph. The first thing you need to do is go over 2 from the origin and up 0 and put a dot. With a slope of 3, we always put whole numbers over 1. So the top number is our rise, the bottom number is our run. So from the point that we have made at 2, 0, we are going to rise 3 and run 1 and put a dot there. You can continue going by rising 3 from that point and running 1. Once you have gotten these points, you can draw a line through the points to get your line on the graph. Now we are going to use the slope of a line, which is 4, and the points x, 6, and 4, 2 to find the missing value of x. The first thing I'm going to do is plot a point at 4, so we will go over 4 from the origin and up 2. Then we will use the slope of 4 to get the next point. Now, if we have a whole number, we have to remember to put it over 1. So from the point at 4, 2, we would rise 4 and run 1. So I will rise 4, 1, 2, 3, 4, and run 1. This would form our line, and it will also give us the answer to our question. When y is 6, our x value would be 5. So x equals 5.
So we're going to talk about slope-intercept form now. Slope-intercept. This is the biggest formula to know in Chapter 6. In order to write slope-intercept formula, you start out with your variable y equals mx plus b. And usually this is a cursive M, and a cursive M you've already learned is for slope, and B is your y-intercept. So y equals mx plus b, and you're going to be hearing that a lot, so get used to it. Writing equations. Write an equation in slope-intercept form for the line that has a slope of 2 and a y-intercept of 6. So we're going to replace our information that we know. So slope is 2, so m equals 2. Y-intercept, our symbol for that is b, and so we're going to replace our b with 6. So let's go ahead and rewrite this. It's going to be y equals 2x plus 6. And that's it. Y equals 2x plus 6. Alright, so we've got some practice problems here. First one here on the left, we've got m equals 5, b equals negative 2. So once again, we start out with y. Y equals 5x, and there's a minus 2. So instead of saying plus, it's going to be minus 2. All right, now for the second one, it's a little bit interesting here. Our slope is negative 1. So you could write y equals negative 1x plus 4, but this is not simplified. The reason is you really don't need the 1 there. That 1 is an imaginary number. So you can really rewrite this as y equals negative x plus 4. And that would be the most simplified way to write that. Now for the third one, we have something missing. Our y-intercept is 0. Once again, I got a 1 for my slope. So we have y equals 1x plus 0. Now, we can totally rewrite this. That we can write this as a much simplified version. It'd be y equals x, and that's it. There's no y-intercept, so I don't need the 0. And I really don't need the 1 there because the imaginary number in front of a variable is always 1. On the top here, I've got 1/2. All right, so we have a slope of 1/2. So y equals 1/2 x, and it's going to be a minus 3. This one is just like the bottom one here, m equals 4, y-intercept, b equals 0. So we've got y equals 4x.
Once again, don't put anything at the end because my y-intercept is 0. I don't need that. In simplified version, if the number doesn't exist, you don't need to write it. On the last one here, I have a slope of 2, so y equals 2x. And it's okay to have a fraction for a y-intercept. It's very uncommon, but you can still have it. And so it's going to be y equals 2x plus 4/3. I'm going to make sure we can see our equal sign up here. There we go. So now we're going to write an equation of a line that has a slope of 3 and goes through the point 2, 1. We don't know our y-intercept right now, but we can figure it out because we know that slope right here is 3. So I can replace my m with 3. And you know for a point, your x value comes first and your y value comes second. So I know that x right here is going to be 2 and my y is 1. So let's go ahead and replace. Replace y with 1 equals 3 times my x value, which is 2, plus b. Now I'm solving for b. Alright, so let's get b by itself. We're going to subtract 6 from both sides because 3 times 2 is 6. What you do to one side, you do to the other. This cancels on the right. 1 minus 6 is negative 5. So my y-intercept is negative 5. So I can replace m over here on the left with 3. My y-intercept is negative 5. So now I can rewrite my equation in slope-intercept form. Y equals 3x minus 5. Alright, so now we're going to talk about the slope-intercept form. For if slope is 1/2 and it goes to the point 4, 5. Hello, hello. All right, so here's our next question. It says, find the slope-intercept form of the slope is 1/2 and goes through the point 4, 5. So, y equals mx plus b. All right, our y value is 5. Our slope is 1/2. Our x value is 4. And we're solving for b. Sorry, my thing's not working too well. All right, so 1/2 times 4 is 2. Bring down the 5. Bring down your plus b. All right, we're solving for the y-intercept, so we need to get b over here all by itself. So we need to subtract 2 from both sides. 5 minus 2 is 3. So our y-intercept is 3. So here's our answer over here on the right. Y equals 1/2 x plus 3.
I'm holding. All right, now we're asked to find the slope and the y-intercept when you're given an equation. The easiest place to do this from is when the equation is in slope-intercept form, or y equals mx plus b. You'll notice that all four of the equations on this slide are solved for y, so this is going to be relatively easy. On the first problem, y equals 2/3 x plus 4, your m, or your slope, is 2/3. The y-intercept is 4. On the problem beneath it, y equals negative 2x minus 3. Your slope is negative 2, and the y-intercept is negative 3. The third equation, y equals 3x, you'll notice there doesn't seem to be a y-intercept there, but there is. The additive identity property allows us to know that when you're adding 0, you don't necessarily have to write it there. So our slope is 3, and the y-intercept is 0. That means that line will pass right through the origin. So beneath it, y equals negative 2x, the slope is negative 2. And the y-intercept, again, is plus 0, so the y-intercept is 0. Okay, so on these questions, we want to find slope, which is m, and y-intercept, which is b. The easiest place to do this is to solve the equations for y equals mx plus b. Due to a lack of space, I'm just going to cancel out these bottom two problems. So we're only going to be doing the top two on this slide. So the first thing I want to do to solve this equation for y is to subtract 5x from both sides. This leaves us with negative 3y equals negative 5x plus 6. And then we're going to divide each side by negative 3. So the negative 3's cancel, leaving us with y equals negative 5 divided by negative 3 gives us a positive 5 over 3x, and then positive 6 divided by negative 3 gives us a minus 2. So our slope equals 5/3. And our y-intercept, which we call b, equals negative 2. All right. So to solve for y on the second problem, the first thing we want to do is subtract 15x from both sides. The 15x's cancel, and we're left with negative 3y equals negative 15x plus 9. Again, we're going to divide both sides by negative 3, and y equals a negative 15 divided by negative 3 is positive 5x, and then positive 9 divided by negative 3 gives us negative 3. So again, we need to find the slope, which is m, and that is 5. And we need to find the y-intercept, which is b, which equals negative 3. Okay, so in the last several slides we were talking about slope-intercept form. Now we're going to talk about a different form of equation known as standard form. The red pen works. Okay, again, we are solving for standard form, which is ax plus by equals c. Remember from the slide just before, standard form, a, b, and c cannot be fractions or decimals. So the first thing we need to do is to get rid of the fractions that are in this first problem. This can be accomplished by multiplying everything in the problem by a common denominator. Your denominators are 2 and 4. So what goes into both 2 and 4 evenly is 4. So we're going to multiply everything in the problem by 4. We're going to go 4 times 1/2 x, 4 times 6, 4 times 3/4 y, and 4 times negative 2. So 4 times 1/2 is 2x plus 4 times 6 is 24. And this equals 4 times 3/4 y is 3y. And 4 times negative 2 is minus 8. So now we need to get our terms, ax, by, and c, all in the correct spots. So the first thing I'm going to do is subtract 24 from both sides, which gives me 2x equals, the 24 is canceled, 3y minus 32. So again, standard form, ax plus by equals c. The 3y also needs to change sides. So we're going to subtract 3y from both sides. Which gives us 2x minus 3y equals negative 32. All right, I hope that made sense. So now we're going to go to the next equation, which is kind of hard to read here, so I'm just going to rewrite it to start off. It is y equals 2/3 x plus 1. So again, standard form is not allowed to have fractions. So again, to get rid of the fractions, we're going to multiply both sides by a common denominator. Since there's only one fraction in this problem, we will multiply everything in the problem by 3. Again, everything, not just the fractions. So we're going to multiply 3 times y, 3 times 2/3 x, and also 3 times 1. 3 times y will give us 3y equals 3 times 2/3 x is 2x, and then 3 times 1 is 3. So in order to get ax plus by equals c, the 2x, we need to subtract it from both sides. And that gives you negative 2x plus 3y equals 3. Okay, so we're going to standard form. Standard form is ax plus by equals c. And we're doing this when we are given a point and a slope. So recall, the best way to get an equation when you know a point and a slope is by using slope-intercept form, which is y equals mx plus b. So in the point, you're given an x and a y, and your slope is your m. So we're going to plug those three parts into y equals mx plus b so that we can figure out our y-intercept. So the y value is 3 equals 1/2 times 8 plus b. Well, half times 8 is 4, so we get 3 equals 4 plus b. We subtract 4 from both sides, and we learn that -1 equals b. So now that we know that the y-intercept is -1, we can write our equation into slope-intercept form. So our equation becomes y equals 1/2 x minus 1. Remember, we're not quite finished yet because we don't want slope-intercept form. We want standard form, which is ax plus by equals c. And in standard form, you can have no fractions. So the next thing that I'd like to do is multiply everything in the problem by a common denominator of 2. Two times y gives me 2y. 2 times 1/2 x gives me 1x, or just x, minus 2 times 1 is 2. So to finish off taking this to standard form, we need to subtract our x from both sides, which cancels them on the right, which gives us -x plus 2y equals -2. ax plus by equals c.
We will now talk about how to find the x and y intercepts of a line. Okay, now we will find the x and y intercepts of a line. The x-intercept is where it crosses the x-axis. So in this case, that is at +2. So we would write the point as 2, 0. The y-intercept is where it crosses the y-axis, which is -6. So we would write it as 0, -6. Here is an example of a line, and we want to find the x and y intercepts, and then we will graph it. To find the x-intercept, we know that if we're trying to find the x-intercept, that the y point is 0. So all we need to do is write x equals 12. And so our x-intercept would be 12, 0. Now we need to find the y-intercept. So what we're going to now do is do -2y equals 12, because we know that the y-intercept, our x-coordinate is 0. And we are going to solve for y by dividing both sides by -2. And so y will be equal to -6. Our y-intercept is then 0, -6. And we will graph these 2 points. So 12, 0, we're just going to have to kind of estimate, would be somewhere over here. And 0, -6 is down here, and then we would connect the line. And we will put arrows on the end since it is a line.
Okay, we will now do two more examples solving for the x and y intercepts. If you're trying to solve for the x, you want to ignore the y coordinate. And the reason you do this is because the y is 0. So you're going to do negative 3x equals 15 and then solve for x. Just like you would any equation by dividing by negative 3. And you will get x equal to 5. Negative 5, sorry. Your x-intercept would then be negative 5, 0. To do y, you would do 5y equals 15. Ignore the x because the x is 0 when you have a y-intercept. You would divide both sides by 5, just like you're solving an equation. And so y would be equal to 3. And so for this, your y-intercept would be 0, 3, since x is 0. Okay, second one. 6x equals 32. To solve for the x-intercept, divide by 6, and you will get x equal to 32 over 6, or if you reduce it, which you always should, you will get 16 over 3. So your x-intercept will be 16 over 3, 0. Now, to do the y, you will get 9y equals 32. Divide by 9. So you will get y equal to 32 over 9, and that cannot be reduced anymore. So you would just have 0, 32 over 9. It is okay to have a fraction as an intercept. Okay, we're going to find the x and y intercepts of these two examples. However, these are what are called special cases, and you'll see why as we go through. So, first one is y equals 7. Well, if I look at what my y equals 7 line looks like on a coordinate plane, you would have your horizontal line through 7 on your y-axis. So my y-intercept would then be 0, 7. But it does not go on the x-axis at all. So you have no x-intercept. So it wouldn't be 0 because you're not going through 0. It would just be no x-intercept. Okay? The second one is the opposite because you have x equals negative 2. So therefore, if we look at this line on a graph, you would have a vertical line going through negative 2. And so your x-intercept would be negative 2, 0. And you would have no y-intercept. And this is why they are special cases. So the thing to remember is if you have a y equals line, your y-intercept is the number, but you have no x. No x. And on the x equals equations, your x-intercept is the number, but you have no y. Okay, this is the last of the x and y intercepts. Just a few examples to make sure we know what we're doing. So let's start with the first one. To get the x-intercept, I'm going to do negative x equals 8. Divide by negative 1. Remember, that's an imaginary 1. And I will get x equals negative 8. And so therefore, my x-intercept would be negative 8, 0. To do y, I would then do 2y equals 8. solve for y, I would get 4. And so my y-intercept is 0, 4. Remember, your 0 is always going to go the opposite place of your intercept. So when you're trying to solve for x-intercept, your 0 goes for y. When you're solving for y-intercept, your 0 goes for x. Okay? Next one. 3x equals 24. If I solve for x correctly, I will get 8. So my x-intercept is 8, 0. Now y-intercept, it's negative 4y because if there's a minus sign, that goes with that term. So negative 4y equals 24. Solve correctly, I will get y equals negative 6. And so it will be 0, negative 6 would be my y-intercept. Now, this one is a special case because it only has a y. So my y-intercept is negative 4. I'm sorry, it is 0, negative 4. Since it is a y, that is my intercept, and then my x is 0. And then for my x-intercept, I have no x-intercept, since I do not have that variable in my equation. Now the opposite is true for this. My x-intercept will be 3, 0. And I will have no y-intercept since I do not have a y variable.
The following section discusses graphing lines. There are 3 different options when graphing equations. One option would be to use your t-table. Remember, when you're making a t-table, you plug in x values and you want to have a positive, a negative, and a 0 that you're plugging in for your x values, and then plot the points. Second option would be to use slope-intercept form, and where you plot your y-intercept and then use your slope rise over run to plot other points and form your line. And the third option is to find your x and y intercepts and then draw your straight line between the two. The goal is to determine which method is easiest for each problem. So let's explore that further. If your equation is in standard form, remember that's ax plus by equals c, the easiest form would be to graph using your x and y intercepts. If the equation is in slope-intercept form, y equals mx plus b, remember that m is slope and b is your y-intercept. First thing you'll want to do is graph using the slope and y-intercept, or again, you could use your t-table to find the coordinates, whichever is easiest for you. If the equation is neither in standard form or slope-intercept form, you want to rewrite the equation in whichever form you'd prefer, and then graph using the methods listed above. Okay, so let's go ahead and look at the graph that we've been given. They give us the equation y equals negative 1/3 x plus 2. If you notice, this equation is already written in slope-intercept form. Therefore, it would be easiest to graph by starting with graphing your y-intercept at positive 2. And then, because you have a negative slope, you'll go down 1 and over 3 to make your next point. Or you could go up 1 and backwards 3. Once you have your points drawn, draw a straight line between those points, and that is the graph of your line. Notice that this is a negative line because we had a negative slope. in the example negative 2x plus 3y equals 12, you'll notice that this equation is written in standard form. Ax plus by equals c. Therefore, we can easily find the 2 points that we're trying to look for on the graph by finding the x and y intercept. So if we're looking for the x-intercept, we would plug in a 0 for the y. If we plug in a 0 for the y, we're left with negative 2x plus 3 times 0 equals 12. Well, 3 times 0 is gone. So you have negative 2x equals 12. Divide everything by negative 2. And you're left with x equals negative 6. Well, this has to be written as a coordinate. So your first coordinate would be x is negative 6, and then your y was 0. So let's go ahead and plot that. Negative 6, 0 is on your x-axis, right about there. If we are looking for the y-intercept, again, you would write the equation, but this time, if you're looking for a y-intercept, your x has to be 0. Negative 2 times 0 cancels out. Divide both sides by 3, and you get that y equals 4. Well, again, it has to be as a coordinate, so you would have 0, 4. So you would go to 0, 4, which is on your y-axis, and then from there, you would just simply connect these 2 points with as straight a line possible. When you're graphing these at home, it would be helpful if your graphs or your lines are drawn using a ruler. That way your line's nice and straight. In our last example, you'll notice that the equation negative 3x equals negative 6y is neither in standard form or slope-intercept form. Therefore, you'll want to get this equation in whatever format you'd prefer. For me, it seems easiest to put it in slope-intercept form. In order to do that, I have to solve the equation for y. So I have negative 3x equals negative 6y. And I am trying to solve for y, so I would need to divide both sides by negative 6. Whatever you do to one side, you have to do to the other. So you were left with, and I'm going to flip-flop this, y equals, and negative 3 divided by negative 6 is 1/2, and it's positive x. So now we've got this in slope-intercept form. Well, you'll notice that we don't have anything adding or subtracting the term with the x. Therefore, we're going to start our graph at the origin. Okay, this is a direct variation. So our first point is going to be right here at the origin. From there, you go up 1, over 2, up 1, over 2, and we'll also want to go down 1 and over 2 just to make sure that we've got our line has lots of points. And your line should look like that. Again, notice we had a positive slope once we solved it for slope-intercept form, and our line is also positive. The last section we're discussing in Chapter 6 is on parallel and perpendicular lines. Parallel lines are lines that never intersect. So you'll want to put that they never parallel lines are lines that never intersect. So write that they never intersect. The reason that parallel lines never intersect is because they have the same slope and different y-intercepts. Okay, for an example, we have an equation that's y equals 1/2 x plus 2, and they want you to write an equation for a line that's parallel to the line given. Well, we just said that they have to have the same slope, and they have to have a different y-intercept. So you can write an equation, any equation that you would like, that starts off y equals 1/2 x. You can put plus 1, 2, 3, 4, 5, or you can do minus anything, as long as your y-intercept is not positive 2. It could be anything in the place of the y-intercept, any coordinate you wanted. Alright, so on some of these examples, we're just finding parallel lines to the equations that are given. On the examples on the left side, they're already in slope-intercept form. So you can write any equation you want as long as it starts out y equals 3x. Anything you want could go in for the b, because your y-intercept just has to be different than -2. So you could say y equals 3x plus 5. Same thing for the second example. It has to start out y equals 6x, and you could put anything you want in for b other than 0, because that's what y-intercept is currently. So you'd say y equals 6x, and for example, you could put -2. The examples on the right, however, are going to be a little bit more challenging because you need to actually put them in slope-intercept form to know the slope before you can find a line that's parallel. So we need to solve the equations for y. So I would need to subtract 2x from both sides. I'm left with 6y equals -2x plus 12. Divide everything by 6. And you're left with y equals -1/3 x plus 2. So you can write an equation for any line as long as it starts out y equals -1/3 x, and you have a different y-intercept from +2. Again, with our last example, we need to solve for y. You would add 10x to both sides. You're left with -8y equals 10x plus 3. Divide everything by -8. And you're left with y equals -5/4 x minus 3 over 8. And again, you can use any equation as long as it begins y equals negative 5 over 4x, and it has a slope, it has a y-intercept of something other than negative 3 over 8. On the slide before, we were given the option to create an equation of a line that's parallel to the line that was given, but we could make up any line we wanted as long as it was parallel. On the example, on both examples on this page, they want us to write an equation for a line that's parallel to the given line, but it has to pass through the point 2, negative 3. Well, that makes this a little bit more challenging. However, all we are doing in this example is we're plugging in 2 for our x and negative 3 for the y in the equation. Okay? First example on the left is much easier because we already have our slope. Okay? So we're looking for a slope and a y-intercept. Well, my slope has to be the same if it's parallel. So I know that I'm trying to keep this same slope. So I'm going to go ahead and plug in negative 3 for the y. And then I have 2/5 times 2 minus, plus b. All I've done here is I am trying to solve for the y-intercept of the line that passes through the point 2, negative 3. Okay? So I plugged in my x, I plugged in my y, and now we're just solving. So I have that negative 3 equals 4/5 plus b. Subtract 4/5 from both sides, and you get that b equals negative 19 over 5. So let's put that in here. So now I am taking this information that we just found. We had to keep our slope the same for parallel, and we just solved for b by plugging in our x and y values. From there, we just write the equation. So we have y equals 2/5 x minus 19 over 5. And this line that we just found is parallel to the given line, and it also passes through the point 2, negative 3. On our second example, again, it's a little more challenging because we have to solve for y first. So when we solve for y, we subtract x from both sides. You're left with negative 4y equals negative x plus 8. Divide everything by negative 4. And you're left with y equals a positive, because we have a negative divided by a negative, which gives us a positive 1/4 x minus 2. All right, again, I know that my slope has to be the same. So I need to make sure that my slope of the new line that I'm trying to find is 1/4. From there, we need to plug in our x and y values again. And this is going to get a little crowded here. So if you have more room on your paper, you can space this out a little better. But we've got negative 3 equals 1/4 times 2 plus b. So all we did was plug our x and y intercepts into the slope-intercept equation using the slope that's parallel to the given line. From here, you would say that negative 3 equals 1/2 plus b. And if you subtract 1/2 from both sides, you will get that b equals negative 3.5. It does not matter if you convert that back to the fraction. It doesn't matter either way. So we have negative 3.5 for our b. We're going to take the information I just squared in, and we are going to write our equation for the line parallel. And you have to excuse me, I'm running out of room, so we're going to write it up top. And you would have y equals 1/4 x minus 3.5. And that equation is the line parallel to the given line that goes through the point 2, negative 3. Perpendicular lines are lines that intersect at a right angle. Okay? To find a perpendicular line, the slope is a negative reciprocal. What that means is that when you're given a slope, you need to take the opposite sign. So if they give you a positive, you make it a negative. And you need to flip the fraction. That's what reciprocal means. So we're going to flip the fraction. Now I know that that doesn't make much sense right now, so let's actually show you what we mean. They want us to write an equation for a line perpendicular to y equals 1/2 x minus 7. All right, so here's what we're going to do. Right now they gave us a slope of 1/2. My perpendicular slope, and this is how you would write it, you would make your perpendicular symbol and then put m after it. Well, like I said, we have to take the opposite sign. They gave us a positive, so I would need to make my new slope negative, and I need to flip my fraction. Well, if I flip 1 over 2, then I would be left with 2 over 1, which is the same as just negative 2. So the perpendicular slope to 1/2 is negative 2. All right, just like with parallel lines, we've got a couple of examples. On the ones on the left, they're already in slope-intercept form, so they're going to be easier. The ones on the right are in standard form, so we'll have to solve for the slope before we can actually find the perpendicular slope. All right, so again, I like to do this every time. I write that my slope that was given was 2, and if I'm looking for my perpendicular slope, I have to take the opposite sign. Well, I was given a positive, so I have to have a negative. And if I flip positive 2, I'm going to have 1 over 2. So the perpendicular slope of 2 is negative 1/2. So all you have to do is plug negative 1/2 in, and you could say y equals negative 1/2 x. And then you could put any number that you wanted in for your y-intercept. The one thing with perpendicular lines is you can have this same y-intercept if you want. Perpendicular lines, that doesn't matter. So if you wanted to say plus 7 there, that would be perfectly acceptable. All right, again, the slope that they gave me in example 2 was a positive 2. So if I was going to find my perpendicular slope, I would take the opposite sign, which is a negative, and I would flip the fraction. So it would be negative 1/2. And you could write any equation you wanted as long as the slope was negative 1/2. Plug any number you wanted in for your y-intercept. Okay. On the second 2 examples, we have to solve for y before we can figure out what the slope is of the given line. Subtract 2x from both sides, and you get that y equals negative 2x plus 2. All right, so the slope of the line that we were given is a negative 2. Therefore, my perpendicular slope, I have to take the opposite sign. Well, they gave me a negative, so my new slope is going to be positive. And if I flip the fraction, I would have a positive 1 over 2 because the slope before was 2 over 1. So you could plug any number in that you wanted for the y-intercept as long as your slope was positive 1/2. Okay, plug any number that you want. Same thing for the last example. We have to solve for y, so subtract 7x from both sides. And you're left with negative 3y equals negative 7x plus 5. Remember, your constant always goes last. Divide everything by negative 3. And you're left with y equals positive, because a negative divided by a negative is a positive 7 over 3 x minus 5 over 3. All right, so let's look back up at the top. The slope that they gave us when we solved for y was a positive 7 over 3. Therefore, if I'm finding the perpendicular slope, I need to take the opposite sign. The opposite sign of a positive would be a negative. And I have to flip my fraction. So my 3 goes on the top, and the 7 goes on the bottom. Again, I can write an equation for any line that I want as long as the slope is negative 3 over 7. And you can plug any number in you want for the y-intercept. Okay, so just like with the parallel lines, this time they want us to find a perpendicular line that passes through the point 1, -4. All right, so remember when we're finding perpendicular lines, we want to take the negative reciprocal. So I'm going to take the slope that they gave me, and then I want to find the perpendicular slope. Take the opposite sign and flip the fraction. Okay? Now that I have my perpendicular slope, I can plug that in for slope and then my x and y. So my y was -4. My perpendicular slope was -2. And my x was 1. And I just need to solve for b. So I have -4 equals -2 plus b. Going to add 2 to both sides. And you find that b is equal to -2. Okay? So now I'm not done yet. They wanted the equation of the line that was perpendicular and pass through that point. So I have to take this information and plug it back in. Well, my perpendicular slope was -2. And my b that I just found is also -2. So I plug that into the slope-intercept equation, and I have that y equals -2x minus 2. And that is the equation for the line perpendicular to the given line that passes through 1, -4. All right, so again, it's going to take a little more effort to find the slope for the line that they gave us, but we'll still write our slope and our perpendicular slope up top just for make sure we have enough space. Got to solve for y to get it in slope-intercept form, so I'm subtracting 2x from both sides. That leaves me at 4y equals -2x minus 4. Divide everything by 4. And you get that y equals -1/2 x minus 1. All right, so the slope of the given line is -1/2. So now I need to find the perpendicular slope. The opposite of a negative is a positive, and if I flip my fraction, I have 2 over 1, which is simply a positive 2. I have to use my perpendicular slope in the equation along with my x and y. So I have -4 for my y equals 2 times 1 plus b. If I subtract 2 from both sides, I find that b equals -6. All right, so now we just have to write the line. So again, you're using your perpendicular slope and your new y-intercept that you just found. So you would have y equals 2x minus 6.